Hello, and welcome to my YouTube channel. So today we are going to learn how centripetal acceleration formula, that is v squared by r or omega squared r, comes about. Okay, that is its derivation, and it's kind of similar what is given in let's see Verma for it. So let us now begin. We take a circle, center. Let us assume this as our initial position, this as our final position, center at O, P at the final position. Let us take this as X for some reason, and this will be theta. Okay, so now then let us begin with it. To find out how much displacement there was from this point to this point, we drop a perpendicular. As this is r, this would be r cos theta, and this is r sin theta. Okay, so r, that is its position vector, which comes out to be I r cos theta I cap plus r sin theta j cap. Okay, in order to find the acceleration, we need to find the velocity first. So we will differentiate it with respect to time. Okay, so it will come out to be r by dt. Okay, dr by dt, and d of r cos theta I cap plus r sin theta j cap all upon dt. Okay, as r is just the radius of the circle, we can take out r because we don't differentiate constants in multiplication. Then it comes out to be r of d cos theta I cap plus sin theta j cap with respect to time. Then we will use the rule, and it will come out to be r into cos becomes, as we know, with respect to d theta. So we'll use the substitution method. Then it will come out to be r of cos theta, cos becomes sin, right, minus sin theta into d theta by dt I cap plus sin becomes cos, that is in positive, that is cos theta j cap d theta by dt. Okay, as we know, d theta by dt is omega, so we can take the omega common from both the sides, and it comes out to be r omega. R omega is v is equal to r omega into minus sin theta I cap plus cos theta j cap. Okay, then after that we need to find out acceleration now. Okay, so for acceleration we won't have to do much, we just have to differentiate this velocity again. So a is equal to dv by dt, then a acceleration vector will be the differentiation of r omega minus sin theta I cap plus cos theta j cap. Okay, now r is still here a constant, so we can take this out. Okay, and we can't take omega out because omega is a vector quantity. So r d omega into minus sin theta I cap plus cos theta j cap upon dt. Here we'll apply the multiplication rule now. Then in multiplication rule, we have to differentiate one side first and take one common, then add it, and then take the other term and differentiate it, and then multiply it with the term not differentiatedly. Let me do it. It will come out to be r of omega remains common, sin theta minus of sin theta we'll just apply the rules in the starting only here. Minus sine theta, as we know, would become minus of cos theta d theta by dt. As you know, sine theta by d theta is equal to cos theta. So sine theta upon d theta into d theta by dt is what we are doing at the end. Okay, so it's omega minus cos theta d theta by dt plus cos theta was not negative, right? So it comes out to be minus sine theta d theta by dt. Okay, now we will have to differentiate omega and let this remain constant. Then it would be d of omega by dt into minus of sine theta I cap plus cos theta j cap. Now we have to observe one thing before doing it, that this minus sine theta plus I cap plus I cos theta j cap is nothing but the direction for the vector. Okay, so we can just take this as 1 actually. And as we knew, d theta by dt is nothing but omega. Okay, so we can take omega out again from these. I will come out to be r of omega squared into minus cos theta I cap minus sine theta j cap plus d omega by dt into r. Okay, and in the direction of tangential. This was the tangent velocity, right? See, this is tangential, minus of sine theta. Okay, then r omega squared. Then we can take minus out of this, and it will come out to be minus of r omega squared. This was nothing but the position vector, and d theta is tangential plus, and r into omega is nothing but v. Alright, so it's dv by dt in tangential direction. Hence proved.